Hello and good evening, everybody. This is Drew Hernandez, Opus IVS. Y'all got to give me a minute. Still trying to get used to this. But tonight's topic is Hyundai Kia, obviously, as you can see on the slide there. We're going to be talking about the GDI motor. We're going to do a little bit of history. We're going to go through some of the models and makes that are there. We will cover quite a few things, and feel free to ask questions anytime you want. Hopefully I can get to you, and we can have some fun tonight. So we don't want to make this any more uncomfortable than what it is. So if you guys bear with me, this is my first time ever doing this. I usually teach in person. It's completely different. So, but we will get through this. So let's move forward. All right, so like I said, tonight we're going to be covering some of the topics. We'll be covering the Theta II engine, the strategy, obviously, of the GDI motor, the operation of the high pressure pump, how it works, what it does, the difference in high pressure pumps, what a low pressure pump is, how it comes into play. Obviously, the direct injectors, which are one of the reasons why we're here tonight, for direct injection, testing the system, right? And what is the pulse width? What does it look like in comparison to your conventional ported engine? How does the direct injection pulse width look? Reading scan data. What do we want to look at when we're trying to fix this vehicle, right? Whether it's a Hyundai, Kia, or any other GDI motor, and also to scope it or not to scope it. What is the best method, right? What is the best approach to trying to figure out what is wrong with our vehicle when it comes into our bays, into our shop? What is it that we need to do? What is the best method? And so we'll talk about that as well. So obviously, with Opus IVS and every free webinar, there is a great offer for a free battery maintainer with the purchase of an ES DrivePro. We need battery maintainers. It's very important that you have one. I'm not talking about a jump pack. I'm talking about an actual maintainer, so that when you're doing any kind of programming, you can monitor the voltage, you can monitor, where it needs to be, and that you have no glitches and have any problems programming. So that's a wonderful offer that they gave us tonight. So with that being said, let's move forward. All right. All right. So our Theta II motor from Hyundai. So as you can see there on the screen, it was announced in November 2009. The sixth generation Sonata improvements, which include switching it over to the GDI. And one of the reasons why they switched over to the GDI motor was to bring down emissions. They want to try to control those kind of things. Whoa, what just happened here? Oh, sorry, guys. It totally went too far. All right, so one of the main engines that you will see in your bays will be this 2.4 here, right? As you can see on the screen, the early versions, were still a little clunky. They didn't really have any boost to it quite yet. But the Theta motor, this is the first one, the 2.4. You can see the compression ratio there. You can see how many RPMs, revolutions per minute. There's some specifications for you on that particular motor. Now, we can move forward, and this is when they started implementing, their turbos. Now, these are the cars that you are more than likely going to see, right? You're going to see these more often, as Genesis gets more popular. But this is where Genesis got its beginning in the 2.0 there. And we can also see that the other 2.0 for the sixth generation Sonata, as you can see, there's more specs for you to look at and to go through. But there's a nice Veloster up there in the left corner there, and you don't see too many of those, but you will see what the specs are for the Theta, motor there. You'll see it here. There's your Veloster that I was talking about. I haven't seen too many of those, but they're there. Obviously, our wonderful Genesis. People love Genesis, right? They're getting more and more popular. So there's quite a bit of makes and models here for us to look at. So you're going to see this quite often, this motor or these engines, you know. So let's try to move forward here, because I'm pretty sure you guys are familiar with these makes and models here. All right. Kia Forte, that's another one that you'll see a lot of. Right. So let's get to the meat. Right. This is where stuff's going to get interesting here. So here's our high pressure pump. Right. What is it? What does it do? Well, it's a compact single piston. Right. Meaning it's very small and it's driven off the cam lobe. Now Ford does that as well. Audi, Volkswagen. I mean, there's a whole bunch of cars that use this method here. Okay, and as you can see in the diagram there, there's a piston, right? And that piston is going to be pushed up and down, obviously running off the cam lobe. Now, this is the most important portion here, is where you can see the pressure relief valve. This is usually where a lot of the things will fail when you have problems with your high pressure pump and with a demand control valve, okay? These two pieces are what's really, really going to help control things, right? The high pressure relief valve is to limit the maximum pressure, right? We don't want our pressures to go exceedingly high. Now, with direct injection, in comparison to conventional engines, the pressure goes a lot higher, right? Similar to a diesel, where you got to, hence the term high pressure pump, right? As you can see there, it can supply anywhere from 100 to 3,000 psi. So that's one of the reasons why you're not going to see a fuel testing port, right, on that line. Nobody's fuel testing gauge is going to be able to go that high. They do have some things out there. I believe there are some gauges that possibly can get that high, but I have yet to see one. There's other methods, right, that we will be talking about in a little bit later. So because it's a single piston, single cam lobe, it does drive off the camshaft, okay, which is going to activate the high pressure pump. Now, the pressure control is controlled by the ECM through the pressure relief solenoid, which is the one that I had pointed out a little bit earlier. Now, that's a very important piece, right? So that tells us that there's really no pulse width there, right? When you're testing the high pressure pump, you're not going to see a pulse width there. You're going to see some actuations, and I'll show you the difference as we get further along, right? And the ECM, as you can see down there, the last point there, it says that the ECM uses the camshaft position sensor and a fuel rail pressure sensor, right, to monitor how much fuel it wants to deliver so that you get an understanding as to what we're talking about. The way the ECM will control this is, it will use the cam position and the crank revolution to know exactly how much fuel to apply, how much pressure that the engine is going to require to continue doing what it needs it to be done. Like, for instance, if you're going to take off real fast from a stoplight or something, right, you're going to need a lot more pressure. Right. So our high pressure pump, here it is, right? As you can see, driven off of the cam, right? As it pumps up and down, you see it comes right through our fuel rail there, and it goes right into our injectors there, right? And as you see on the bottom of that there's a roller. That's one of the differences between the Hyundai model and a lot of the other vehicles out there that are using the same Bosch high pressure pump, is that this one has a roller at the bottom of it. Okay, so let's talk a little bit about its operation, right? So there are two modes of operation the high pressure pump, right, which is the suction stroke, which is a low pressure, right? Fuel enters the pump, the demand control solenoid is de-energized, right, the valve, allowing fuel to enter the pumping chamber, right? During this time, the piston is at bottom dead center of the camshaft lobe, right? As the lobe begins to move from bottom dead center towards top dead center, the piston moves upward and compresses, the fuel, pressurizing it. At the same time, the demand control valve solenoid energizes, closing the inlet valve to the low side pressure. So with the piston continues to compress the fuel, overcoming the outlet valve, right, or the spring that we saw earlier, and any existing high pressure, right, it's able to deliver high pressure fuel to our fuel rail. Now, all that being said, right, let's take a better look at it. Right, let's take a much better look at how all that what I've just said, because if it was me listening and watching that video, it just doesn't make any sense, right? So let's take a better look at that. So here's our high pressure side of the pump, right? Now you see the yellow square in the middle and my little makeshift arrow that I made. As the piston goes up, right, when it's being pushed by the cam lobe, our solenoid is going to close, as you can see right there from number 6 and number 5. It's going to close, and everything in red you see in there is going to push past that relief valve, which is number 3. Okay, and once it does that, you have high pressure flow coming out of B, which is going straight to our fuel rail into our direct injection injectors. Excuse me. So hopefully this helps you to understand what I just said about the high pressure pump, right? There's 2 cycles. So this would be the, pressure stroke, right? The suction stroke, right? Which I had mentioned earlier would be here, right? So now, as you can see, we're on the other side of the pump here, right? And our yellow bar is making its way down. And as you can see the cavity there, it's going to suck and allow the low pressure fuel to come in on that side of the pump, right? Make its way through the filter at the top, right? It's going to just kind of resonate there until that piston pushes back up, pressurizing it, going back to where we were at, right? So that's the high pressure pump operation, right? So our high pressure pump operation, that covers that, right? It's a very small thing, but here's our low pressure pump. Everybody's familiar with these, right? Good old in the tank fuel pumps, right? We all have seen these. We've replaced plenty of them on many other makes and models. But what's the difference between this one, right? So here's the difference between the low pressure pump on a GDI motor and most ported engines. Okay, is our low pressure pump here will put out anywhere from 65 psi up to 70 psi. Most ported cars will stay roughly around 35, depending on make or model, maybe upwards to 65 or 60. But on average, they're usually anywhere between 45 to 55 psi, right? And that's a ported, and that's going to be always there, and it's always supplied. It's going to be constant as long as that pump is moving. This one is a little bit different by the way it's operated. And by the way it's operated is you find it more and more common in these vehicles nowadays where it's modulated. So the pump itself is modulated because it needs to be able to supply that demand that the high pressure pump wants. And it allows the ECM to have more control over fuel volume and fuel regulation. So for the most part, this is what our low pressure pump looks like. You would know it as a regular fuel pump, but it does not operate the same electronically. But as you can see, it's very similar, right? Very similar to what we know traditionally. Okay. So with that being said, let's go forward. The strategy of the GDI. All right. Let's take a look at some of the basics here. All right. Let's just slow down a little bit because I feel like I'm going a little too fast. But see this component here? It's very, very important. See, these drivers inside this module here are going to supply high voltage to your direct injectors. Okay. Now those direct injectors need that so that it can spray the right amount of fuel. We'll get to that in a little bit. But as you can see here, it tells you exactly it's an electric motor for the fuel pump, what our fuel pressure should be on the high and low side, especially for these GDI engines on Hyundai. Now, this specification is for Hyundai only. They vary from make and model. Okay, they vary from other makes. But as you can see there, the high pressure can go up as high as 2100 psi. Okay, so that's pretty normal, right? So this is why we always want to take safety precautions when we do start getting into these things and attempt to test things. So there's always procedures that you want to follow, okay, that will keep you safe when operating these things or trying to test them. So these drivers, right, are going to send high voltage to our injectors, right, and it's also going to supply battery voltage to our high pressure pump. Okay, and it's going to control everything completely. So there's got to be a way to monitor it, right? So the way it monitors the fuel delivery is through our fuel rail pressure sensor, right? And I don't know if anybody out there has ever worked on diesel, but it's similar to the way a diesel works, right? We're going to have what they would call it a common rail. So with direct injection, it's very similar to a common rail. Okay, so the PCM in a PFI or a regular ported injected vehicle will base its inputs on the need or the fuel that it's needed, right? That's where our pulse widths come in play, right? If you're familiar with how a pulse width works on an injector. So on a GDI, it doesn't go off of the same strategy, okay? And this is why I mentioned the fuel pressure rail, the fuel rail pressure sensor, right? Tells it to the computer, it reports to the computer what is the pressure inside the common rail at any given moment. So that the computer can use the pressure to calculate how long injectors should be open, the boost pressure if the engine has a turbocharger on it. Then the pressure side, the intake manifold, is going to be greater than the atmospheric pressure, and that means more air is going to enter into the cylinder, and the computer has to match that with the fuel, right? Hence so it uses the coolant pressure, the coolant temperature sensor, right? As well, right? And we're very familiar with how most cars have used the coolant pressure, the coolant pressure temperature sensor. Oh man, that was a bit of a tongue twister. The coolant pressure test, Lord help me. The ECT, okay. In the old days, to monitor, fuel, okay, and to choke out the system if it needed to, right? Well, on these models, it is very imperative that the coolant temperature is where it needs to be as well, for not just putting it into a closed loop, but also to monitor, fuel. So, it uses that against air. So this is why when you're on the turbocharged systems, you'll find air temperature sensors, right? Why would we want to know what the air temperature is coming in and out of a turbocharger? Well, that's the reason why, in the same sense that we used to use, or we still use, temperature sensors. So let's talk a little bit about the fuel rail pressure sensor, right? The fuel rail pressure sensor provides feedback to the ECM, which I was just talking about, which regulates the fuel pressure by varying the volume of fuel being delivered to the high pressure pump. Okay, this is what I was talking about earlier, how it controls the low side, right? And it works all together. It's completely controlled by the ECM, right? The ECM has its own internal calibrations for each car. Each make and model is different, obviously, to calculate the desired fuel rail pressure, right? And the injection duration according to the accelerator pedal position, engine speed, load, and temperature. So the rail pressure sensor is calibrated to an output signal from anywhere from 0.5 to 4.5 volts, okay, with changing pressure. So this is, for those who are familiar with what a piezo is, the same way a knock sensor works, or the same way, anything that has a piezo in it, it fluctuates, right? The voltage will move up and down based upon the pressure, right, across these crystal plates. Okay, so that's how it's monitoring that, right? As you can see, any voltage above or below these values, for example, either 0 or 5, will indicate that the sensor has failed. So that's a good note to have, right? There are a lot of defaults out there that some people are not aware of. I forget about that sometimes when I'm making calls. There are things like when some sensors are unplugged, you'll get a default of like negative 40 degrees Celsius, right? It may not always give you an open circuit code, but you'll see it, right? So these are some of the things that you do, right, when you're diagnosing a vehicle or you got something in your bay, right? Before we start getting all crazy, right? We look at some scan data, right? We want to see what it's saying, what the guy in the dashboard is trying to tell you. So these are actually good specs to know. So if you ever get one of these cars and you get a signal or a code for your pressure sensor and you see that it's at 5 volts or it's at 0, we automatically know that the winding or that sensor inside is no good, that the piezo is not functioning the way it should, right? A high pressure system leak can be indicated if the sensor output is too rapid, all right, and drops to about 0.5 of a volt. Now, we will talk about this in a little bit when we get to talking about how to scope out one of your injectors, okay, or even the high pressure pump. And there is some techniques we're going to talk about because, like a diesel, this system is a peak and hold. Okay, so there are things that we can do to induce the engine to default to a high pressure, right? And we want to monitor the bleed off or the decay, right? But we'll get to that in a little bit. So as you can see, we were saying if it drops rapidly, right, after the engine has been stopped. As it might occur with a leaky injector, rail pressure regulator, inlet metering valve, or pump. So, for example, waveform, right? We're going to get to that in a little bit. With an engine fully loaded over a prolonged period of time, and this is what we're talking about with the decay. So, I don't want to spend too much time there, but they are important. They are a very good place to start your testing if you're suspecting that you have a fuel issue on a GDI car. Now, here we are, direct injectors, right? Here's our driver unit again, as you can see, right? Our direct injector, which is directly in the cylinder, as you see in the image there. And, you know, this is just a quick overview, but you can see on our right there that this direct injector is a little bit dirty, right? We all know about GDI having carbon issues, right? We'll talk about that a little bit more. Reason being is that it's directly in the cylinder. Traditional ported vehicles had the injector on the back side of the valve, of the intake valve, and as it sprayed the fuel, it would clean off that valve. Okay, we no longer have that with the GDI, right? So this is why carbon tends to build up on the intake side. Also, this is one of the reasons why Toyota now has, it's got dual injectors, right? It's got one for the ported side, and it's got the direct injection on the other side. So it's got double injectors. So yeah, we'll get to that some other time. Thought I'd make a mention of that. So GDI injector testing, right? If you're new to GDI injectors, they are a far cry from the normal PFI style injectors, right? GDI injection uses different ways to trigger their injectors, as well as vary the pressures in their GDI engines. The high pressure, the fuel rail changes according to the demand. By definition, this means that the electrical conditions will be changing, okay, as well. So on a PFI injection system, the pressure stays. This is what we were mentioning earlier, about 35 to 60 psi, depending on the system, right? On normal PFI injectors will draw about 900 milliamps. Okay. On the other hand, GDIs use a peak and hold triggering scheme, right? Much like the older big throttle body injectors, with the difference being that the voltage and current values employed by GDI injectors, internal resistance ranges between 2.6 to about 16.3 ohms, right? That's ohm testing. I'm not very big on ohm testing myself personally. I'm more I like to see the flow of things, me personally. But this is some specifications for you if you're into those kind of things. Now, depending on the application, the following will explain exactly why and how GDI injectors are triggered, and how to test them, analyze them, with your picoscope, with a waveform, and we'll show you how to read that. Okay. Oscilloscoping or graphing multimeters are a typical GDI injector current waveform, shows a few points of interest, right? We're going to get to that in a minute, but because they're a peak and hold, they're not your traditional waveform. It's going to look a lot different than what you're used to. Okay. They have a sudden rise in current. This is the turn on point and go as high as 12 amps. Okay, they go pretty high. So a lot of the times, to be on the safe side, sometimes you want to put an attenuator if you're using a scope on that, so that you don't damage your scope. Okay. So GDI injector again. Okay, it all depends on the fuel demand for a particular engine condition. The turn on of the current value will change according to the demand. They open much faster than a regular PFI injector, right? A normal PFI injector is about 0.4, 0.2 milliseconds or somewhere around there, compared to the typical, 5 to 15 or higher, right? So there's a lot to talk about when it comes to the injector. But what we want to take away from this part here mostly is that the GDI injector, it at high pressure, right, will spray in some vehicles in a certain pattern, right? It needs to be in a certain pattern because some engines are using like a swirl type technology to get the air into the cylinder a specific way. That way it combust better and cleaner, warming up the engine faster, all these different types of things, right? But that's what that GDI is really big difference at, not only in voltage, but the way it sprays very small and precise amounts at a very high pressure. So heat has a big variance on this too. So let's say you're running your vehicle, and the vehicle comes in hot, right? Normal operating temperature. You turn it off, and you're looking at your data, and your data shows that the fuel pressure and temperature is let's say it's about 1500, right? 1500 psi, and you turn off the vehicle, normal operating temperature. You let it sit for a few minutes. The temperature and the pressure will rise. That's because of the heat. The injectors are usually nestled in between, for instance, like Chevy and Ford, buried in the middle of the motor, right? Some of these V6 engines as well will have that same scenario, and because of the heat, it makes pressure rise. So don't be surprised or fooled by that if you're monitoring your data, right? All right. So with that being said, we definitely want to keep an eye on that. So as you can see, now we were talking about piezo earlier, right? Now, for those of you who do not know what a piezo is, okay, piezos are used, or piezo, however you want to say it. I'm not, going to say anything if you say it wrong. But as you can see in this image here, this is what the inside of a direct injection looks like. Okay, so it is controlled by piezos, stacked piezos. Those little lines that you see in there are stacked, and they will fluctuate. They will move up and down based upon the voltage, right? Depending on the level of fuel that it wants or is demanding by the engine, right? And it's delivering. And as you can see, it's just going to move that pintle up and down. See how small that is, right? It's very, very, very small, but similar to a diesel injector, right? A diesel injector does the same thing similarly. What it does, it will fill it up with diesel, compress it, and then pushes it into a hot cylinder, right? And there's no need for a spark. Once the engine starts, it's going to just keep going. Well, same idea here, right? But it's the piezo that will move and allow us to do this with gas. Now, whoops, my bad. As you can see here, with my slide that's malfunctioning, you can see with the slide there that the piezos, how they will move up and down with the voltage. And as you can see, this is why they demand so much voltage, right? To get those plates to move up and down as quickly as they can. As you can see, the flow of the fuel when it's closed and when it's open, right? So this is why scan data is very important when we're trying to diagnose things, right? We want to understand how this works. Okay, I really wanted to spend a little more time talking about piezos, but I'm kind of running out of time here. I think I'm moving along a little too fast, and I really want to get to the meat and potatoes, so they say, right? So scan data. When we're looking at scan data, one of the things that you want to look at is desired fuel rail pressure, if that pit is there, right? If the desired is not there, it may say set point, right? Hyundai is really big. They're a little bit different about a lot of things that they do. And set point is basically going to be your desired fuel pressure, okay? Same thing, right? The actual pressure is going to be what's there at the rail, right? Or in some cars, it'll say fuel rail pressure. Okay, so those four there are kind of interchangeable, right? What you also want to look at is, like I said, we were discussing earlier about how the injector pulse time is, or the voltage of these injectors, how it's a little bit different, and how we can see if one's leaking or not, right? Well, we want to monitor that too when we're running the vehicle. You want to take a look at that. If that pit is there and you can see each one of your injectors voltage-wise and what it's putting out per millisecond, then you're definitely going to find out if one is plugged or if one is leaking. You'll see that the numbers won't really match, right? You also want to look at your low pressure sensor, right? We want to know and monitor, see if it's bleeding out, right? Because sometimes that's some of the problems that these things have. And obviously short-term and long-term trims, right? And generic scan data. Now, the reason why I put generic scan data in there is because with Hyundai, it's not going to say short-term, long-term, okay? With other vehicles too, it's like, for instance, Nissan. It's not going to say short-term, long-term. But under the generic data, you'll be able to get that kind of information. And that's invaluable, right? Before we go tearing things apart, and just saying, oh yeah, this is what it is because this is what happened on the last one, right? We really want to just get in there, test some things. We want to get some information first, right? So it's like going into surgery, right? The doctor wants to see you first, right? Same thing with scan data. We definitely want to monitor scan data. So scoping the GDI engine. This is where I love doing. It's one of my favorite things to do, actually, is scope anything I can get my hands on. I'll probably scope a dead bird if they let me. Anyways, so here's our peak and hold method, right? As you can see, there's a big ramp on our left side. It goes straight up, right? That would represent our peak, right? It's going to shoot straight up the voltage, right? Because what is an oscilloscope? It's basically just measuring things in current or in amperage, right? It's going to take pressure, right? It's going to read those pressures. Same way the ECM is reading its information to determine what to do with the vehicle as far as delivering the fuel, right? Is what we use the scope for. So I can physically see with my eye what's going on. So as you can see, as it shoots up the current, right, it's going to pulsate a little bit. That's the hold, okay? And then when it drops back down, right, it's closing it off. But as you can see on the bottom there, when it goes up to its peak, begins to spray the injector, it holds that injector open for a little bit and then closes. Now, the reason why I have this other one up here, which is a poor picture, you got to forgive me, is you can see how quickly it turned on. And as you see right there, that's not a misprint. See how it says 60 volts? This is why I was saying that on some makes and models, because of the amperage and those drivers that the ECM is using, you will get some high voltage going straight to those injectors. Okay, so you definitely want to be protecting your scope if you're going to be testing these injectors. Okay, but you can notice right here that there's 2 step downs. Now, not every vehicle will have that. And this picture is really not doing any justice of what you would really find out there in the field as far as Hyundai. Okay, Hyundai will only have 1 step, just so you know. But I'm showing you the 2 because GDI it started way back in '97, right, with Audi and some of the European countries. But it was Hyundai who brought it to America, okay, and really kind of broadened the spectrum for everybody. Now it's a normal thing to find a GDI motor in almost all makes and models, okay, almost. But you will see here, this is what you would find in some of the other vehicles. As it peaks up, and it'll step down 1 or 2 times. So you're not always going to find that, okay? Just be aware of that. So here is a known good. Lucky me, I work for Opus IBS, and there was a Kia Optima that came in, and I was able to jump on it real quick and grab some information. Now, as you can see here, there's our peak and hold. This is what you will see when you back probe the sensor at the high pressure pump, the control valve, okay? As you can see here, the blue trace will be power, okay? And the green trace, just for giggles, I went on the ground side to see exactly what it was doing, because I'm a weirdo like that. I like to see everything. But if you take a look, right, our ground control, this is a ground side control circuit, okay? There are some, be careful, there are some Hyundais and Kias that are power side controlled, okay? But for the most part, you will run into, it's usually ground side. So blue trace is the power, right? This is that solenoid that I was telling you about that's opening and going to close, and it's going to create that high pressure, right? This is just one event. This is about 5 milliseconds, probably less. I didn't put that up there. Didn't really measure it, but this is roughly about 5 milliseconds here. That's how quickly this thing will activate, okay? What I found interesting is that as the power side shot up, right, and peaked it, look how much amperage it drew, right, on my ground side. It actually brought it down, right? Then it kind of stabilizes, and then when it shuts it off, we get a little peak there with the with the ground side that almost mirrors it. But this is a known good. Unfortunately, I didn't get it done in time. There was a customer that I was helping out earlier today with the Sonata that was having some issues, some drivability issues with their fuel delivery system. And he sent me some pictures and some videos, but I just didn't have enough time. So if you guys email me, I will gladly share those with you and send those out to you so that way you can see exactly what a bad one looks like. Okay. So that brings us to pulse width. How does it work with this vehicle, right? How does that work, right? Well, here we go. Here's another capture, right? Now, as you can see with my poorly pictures here, my injector voltage is going to be my channel A, which is the blue one, right? As you can see there. Channel B is also my my injector, and my injector current on the top there. Now, remember I was saying about it stepping down and having two steps and one step. That's exactly what you see right there on that green trace. That injector shooting straight up, boom, peaking, holding, oscillating, and it's going to hold for a little bit, spray, and then close, boom. And these are all three events here, okay, from the injector to the pump. And this is what you want to see, okay, if you're ever in that position to test, right? So let's get to the fun stuff, right? Common issues. Oh, yay, it's a GDI. First thing I'm going to look for is carbon. That's true, right? Right? Carbon can cause a load of problems, right? As we see here, right? We can see that valve is completely carboned up, probably hanging open, and causing a whole lot of misfires and a lot of fun, right? Causing a lot of fun. So, so our email. I'm sorry, I wasn't paying attention to the chat, but my email is drew.hernandez@opusivs.com. Okay. All right. So let's get back to what I was talking about. Carbon. Wonderful carbon. Now, we already talked about how that is explored. Now, if you really want to have some fun and do a little research on your own, I challenge you to Google microscopic soot. That, my friend, you will find is basically a scientific word for carbon. And it'll be in the valves on the side of the engine walls. It'll be in the oil pan. It will build up anywhere it possibly can. Is there a way to clean it? There are various cleaners that are out there. Kia, I was looking for it. I don't know if they retracted it, but Kia used to have it in their driver's manual, where it advised you to put in Chevron with Techron every fill up. You wanted to put 2 bottles in, and this was their way of trying to minimize the carbon problem. But you still would have it, right? Intake manifolds plugging up, valves sticking open. Some of this stuff will get as hard as a rock. I've seen carbon build up about the size of a dime once. Had to replace a motor because of that. So yeah, here you see right there. This one's actually not so bad, but you will see some pretty wacky things, One of the other things alongside of carbon is that you will get this little bad boy right here. This is the roller that goes in the high pressure pump. Now, one of the common issues that we get a lot, okay, is somebody will do a cylinder head job or some kind of work on the engine, and they shipped off that cylinder head block and they leave this little bad boy inside. They are unaware that it is sitting inside on the cam, but when they get it back, their cylinder head, it does not have this little guy in there. And then you start getting a very low pressure code. It would be a P00, I think it's 86 or 87, right? And that's because this little guy is missing, right? Also, one of the other things I want to mention is that the wrong viscosity of oil. Okay, as you can see, there's a roller on the end of this. For those who work on Fords, right, are very familiar with those 3 valves, right, where the roller would bind up and you would eat away at the cam, and you got a cylinder specific misfire because, well, that valve is worn out, right? The lobe is worn out. Well, same thing will happen here. You use the wrong kind of oil, this will wear the cam that drives it. Not only will it wear the cam that drives it, but it will damage this roller. If you damage the roller, guess what? You're going to have some problems with your high pressure pump, right? At that point, if you suspect that you're having a pump issue on the high pressure pump, one of the first things I like to do is I'm a lazy kind of guy. Okay, I like to go after the low hanging fruit. I'll pull out the dipstick. And if it's full, over full, I'll grab a little some on a rag or grab some with my finger and take a look and smell it. If it smells like gas, guess what? It's leaking from the high pressure pump into the crankcase, right? Probably from a damaged roller or a damaged pump. So there are many, many variables that are out there. Okay. One of the other ones there is we have this wonderful bulletin here. You see this bulletin there? This is another common issue that some look past, as you can see from the campaign. This is for a Veloster, right? Now, one of the problems that they have is that the pressure, the line, the high pressure line will bind and kink. How does that happen? You say it's made of aluminum, right? It's made of metal. How does that happen? Well, as the engine shifts and moves, right, it will bend and pinch over time. Again, you got to remember this is high pressure and it sits in a very hot part of the engine, and it can get very hot, right? And it'll easily bend, kink, and break, right? Or not even break, but it'll just kink up. You'll be sitting at an idle, and it's great, right? You got great pressure, great data reading, everything's beautiful. Give it some gas, and all of a sudden the pressure drops, right? That's because of this TSB right here. And as you can see, it says P0087, right? Which is going to say you have a pressure problem, right? The pressure's too low. So these are some of the things that you'll get, right? These are some of the codes that most people will get commonly, okay? Very, very common, all right? So as you can see here, it points out how these lines will kink and bind. This right here is just showing you on this particular motor on how to go about the repair, right? So we're kind of mosey our way through this right here. Again, Lowside, see, wonderful Lowside traditional pump. You would think they'd make it easy for you, but they don't. Welcome to the wonderful world of automotive. All right. As you can see there, they're pulling it out from the bottom. So it's very easy to miss these kind of things among the common issues here. So to get back to my point about, are there any cleaners out there? There are various things that are out there. I'm sure there's not a shortage of YouTube videos of people talking about how it worked or how it didn't work. But I will advise, though, okay, seeing how this is a high pressure system, you're not going to be able to do like your traditional, fuel injector cleaner. Although there are some that are out there. I'm not a very big fan of them, but there are induction cleaners out there that you can explore. ATS makes one. There's quite a few out there. But that being said, let's move a little forward here. All right. So, all right. Here's another beautiful. I took this off of one of our SI service information sites, and this I thought was interesting, right? This is for our P0087 again, right? Too low, right? And look what it tells us, right? This is some of the things we're going to run into out there in the field. It's going to say, oh, our fuel pressure sensor, our high pressure fuel pump, wiring connectors, PCM, right? Then you probably get a trouble tree that's going to point everything out, and it's going to have you replace everything in its mama, right? You know what the problem with this vehicle was? it was a kinked line, right? very, very simple, right? So earlier today, though, you see the image here with the individual that I was telling you that I was talking to about his fuel problem. His problem was with that sensor right there. It was reading a default value of 9,000 psi. There's no way it was 9,000 psi. I'll tell you that right now. He opened the high pressure line and it just dribbled out. So again, here we are, an exclusive offer for this webinar, right? Wonderful free battery maintainer with purchase of the ES DrivePro. Again, if you're doing any kind of flash programming, if you're doing any kind of anything, a battery maintainer is crucial to any kind of programming. Okay. As you can see there, the offer ends on 2/24/21, so you better act quickly. As you can see, you get to pay $0. All right. So let's get down here. So if you need any support on any make and model, if it has to do with Asian and domestic, again, my name is Drew, and I work with 360 Support. You'll probably more likely get me because I am not afraid of breaking things and helping you fix it. So do we have any questions?
All right. Hey, Drew.
Hey, how's it going?
Good. How are you doing?
Oh, thirsty.
Yeah. All right. Well, thank you for all that great information. Hey, guys, I'm Gina. I'm going to help lead the Q&A today. Let's see what we got here. Okay. So, all right. So we got Charlie Fallon asked, what voltage do the injectors use?
That varies from make and model, but on this one here, as you can see in the slides that we were at earlier, they can be upwards to 50 volts. They can be upwards to 60 volts. But on average, when you're testing things, you'll get anywhere. I usually put my meter at a 20 volt scale just to be on the safe side. If it goes over, then but most of the time a 20 volt scale is good. So.
Do top engine cleaners harm internal high pressure pump components when doing an injection cleaning?
Yes. Well, yes. I, in my opinion, they do. Again, the wrong viscosity of oil can damage that roller or damage the cam roller on that high pressure pump. So it can cause some problems depending on the severity of sludge buildup or carbon that's built up in that oil because of the direct injection. Yes, it can. I've seen people do it, and get away with it. I'm not that kind of guy to make that kind of risk, though.
Okay. All right. What do we got here? Can you see the deviations in the intake manifold vacuum waveforms due to carbon? And how can carbon be verified during diagnosis? I think those are two separate questions. First being vacuum. Can you see the deviations in the intake manifold vacuum waveform due to carbon?
Yes. Depending on the type of, well, not with scan data, okay, but with a lab scope, and depending on what kind of sensor you use, you can if you're fancy and you got the WPS 500, oh yeah, you'll definitely be able to catch it. If not, you can get yourself a regular piezo sensor and plug that in as close as you can to the throttle body and get some capture waveforms of the intake and exhaust moving, and you'd be able to catch that. Just the same way you would be able to catch like a valve adjustment on a Honda or something like that using the same Delta sensor.
All right. And Jeff Robson also asks, how can carbon be verified during diagnosis?
How can it be verified during diagnosis? As far as the carbon on the valves or on the intake?
It doesn't specify. How can let's see.
Well, if you have a carbon issue and you're scoping the vehicle at the intake manifold, or that's probably the only place you'll be able to scope it at. You'll be able to see the pulsations will be irregular. So you'll be able to verify whether it's on the intake side or the exhaust side. If you have a WPS and you go in cylinder, you'll definitely be able to catch that, and you'll be able to see the deviation right away. It all depends on what make and model you're looking at, and to answer that question. But for Kia, you can get away with the Delta sensor, and you'll be able to see the deviation as far as the pattern not looking the same as some of the others. You'll see the deep pull of a deep pull of extra vacuum, which usually indicates that something is open, right? Or hanging open or closing too soon.
All right. Next question. Okay, so we got, I'm going to butcher this name, but, okay, so hey, Drew, during the class, you said you would scope a dead bird. My question is, where do you hook up the leads? That's funny.
One at the beak and one at the claw. That's funny. So I see a question here that says, are all direct injection injectors piezo type? From what I understand and from what I know, majority of them are. I have yet to see any other kind, and I've worked on a variety of cars. That just seems to be the best method for direct injection and the high pressure and the volume that it needs and the accuracy that it needs. The piezo is seen, the stacked piezo crystals are the best method for direct injection. I have yet to see any other kind.
Right. Is it common to have high pressure injectors leak compression?
Is it common? Oh, again, that depends on where you're at, right? If you're in a place that, say, has a lot of weather changes and things deteriorate due to the weather, you know, one minute it's winter time and 2 o'clock rolls around and and it's now summer. Sometimes the seals on the end of the injectors will wear, and you will get some vacuum sucked in through there. But as far as the direct injectors, it's a 50-50 thing. I've seen more pump failures than I have injectors. Usually when you have one injector leaking, that's usually how it goes. You'll know right away. You'll have some crazy codes for fuel trims and things like that.
Okay. So Alberto asks, why set DTC P0088 just in cold start and set limp mode? You see that question in there?
Let me see here.
Alberto.
Let me scroll through here.
To the top.
I see Oz. Oh, here we go. Why set DTC P0088 and just cold start and set limp mode? All right. Again, that's going to be a fuel volume code. Okay, so there's going to be some problems. Either the pump isn't functioning correctly, right? You need to look at your scan data on a cold start and see what it's reading. See what your pressures are actually at that place. For it to go away when it warms up, could be a weak low pressure pump, right? Not providing enough fuel to the high pressure. Or you could possibly have a leaky injector or a leaky high pressure pump that would cause that on a cold startup too, right? So if you get in some wacky trims and things smell like fuel, then you definitely want to go inspect those things. Some of the things that we covered in this session tonight would be ideal to go through that and figure out which end of that system is giving you the issue.
All right. Thanks for that. Okay, we got time for one more question. Any questions that we don't get to tonight, please feel free to email us at webinars@opusivs.com and we'll get your questions answered. Last question I'm going to ask tonight is, does rail pressure after a hot soak raise with KOEO to verify leaking injector.
Yes, fuel rail pressure does rise when it goes up. One of the best methods for finding a leaky injector is what I do is I get the vehicle up to running temperature. Okay, I disconnect the high pressure pump solenoid, because usually it'll default. When it defaults, it's going to put the maximum pressure into the system. Okay. You can actually figure out if you're on the ground side or on the high side, and you can actually short it out for yourself and get maximum pressure. It doesn't hurt nothing. It doesn't hurt the pump, doesn't hurt the PCM, doesn't hurt anything. You get maximum pressure, but I'll be back probed at the fuel rail pressure sensor, right? And I will watch the decay. Now, if my decay comes down, like let's say it's at 4.5 volts, it's at its max, okay, and it drops down to like 2.5 in like 5 minutes, I know I got something leaking somewhere. And then at that point, you break out your wire diagram and see if you can get into one of those injectors and see which one is actually causing the leak.
All right. Well, thank you for all that great information tonight, Drew.
Mm-hmm.
I know it was your first webinar, but you did a good job.
Well, thank you. I'm so nervous. I've aged like 20 years.
All right. Well, thank you everyone for joining. I hope you have a great night. A follow-up email will be going out with the PowerPoint presentation PDF, so look out for it probably tomorrow. Have a great night, and thank you for joining us.